In this lesson, we're going to be looking at solving compound inequalities. But first, we have to understand what exactly a compound inequality even is. So if you look at the top of your paper, you'll see some blanks. So compound inequalities are two inequalities joined by the word and or by the word or. Inequalities joined by the word and are called conjunctions. Inequalities joined by the word or are called disjunctions. Now, if you'll think about even in English class, you use the word conjunctions, okay? So it's kind of very similar to English where you have two problems and you're going to join them together with a conjunction. So two real life examples to help you make sense of what a conjunction is and what a disjunction is are these two here. So if you'll look at the conjunction, you have a speed limit. You will see this sign on most major interstates where you have a maximum speed of 70 but a minimum speed of 40. So what is going on here is it says cars driving on the highway have a min speed of 40 miles per hour and a max speed limit of 70 miles per hour. So if we translate that, it looks like this. You must stay at or above 40 and you must stay at or below 70. Now, if you'll look, this is a compound inequality because there's two pieces of the inequality. So these are what we consider to be safe speeds. But if you also look here at the graph looks similar to this. So if you have 40 here, so 50, 60, 70 here, you can see they are both closed. So they are both included. And this one tells you that the speed limit above 40 is safe, and this one tells you below 70 is safe. You get a graph that looks like this. Now, this is a connected graph. Therefore, conjunction is going to be your connected graph. We also associate this with and. So the conjunction and is your conjunction. Now, we will write the inequality like this, but we typically like to write these connected. So if you look at your graph, you will see that all x values are below or equal to 70 or above and equal to 40. This is what an and compound inequality will look like. Now, over here we have a disjunction. And if this one's connected, we can think of this one being disconnected. And we associate this one with the word or. So here is an example of a disjunction. Children 3 and under and senior citizens 65 and older get in free. So we have two different situations going on here. Children 3 and under or senior citizens 65 or older get in free. So this is the people who get in free, and you'll notice the word or in the middle. So if we travel down here and do the graph, let's put 3 here, we'll put 65 way over here. 3 and under get in free, or 65 and older get in free. This is the disconnected graph. The two rays go in opposite directions. So this is what we consider to be a disjunction. So, a conjunction is connected with and, a disjunction is connected by or. They are disconnected. These are the two basic types of a compound inequality. So you have two inequalities connected. Two inequalities connected with the word or. Now, let's look down here at the translating part. You have a verbal description, some possible solutions, an inequality, and the graph. So here, all numbers greater than -1 and less than or equal to 4. So what are some numbers that works here? Well, all numbers greater than -1, well, 0 is greater, 1 is greater, 2 is greater, and so on. But then it also says and less than or equal to 4. So we can really only go up to 4 because it says less than or equal to 4. So what would the inequality look like? Well, if we come over here and we say, okay, it says x is greater than -1 and less than or equal to 4, it looks like that. So if we go over here to graph, we have a -1 that is open. We have a 4 that is closed. X is greater than -1 and less than 4. So you can see here we have the word and, so we have a conjunction. Now, we can write it this way, but like I said, it's typically written like this. The x's all fall between here. It is less than or equal to 4, but it is also greater than and equal to -1. Now, it's an important note that you notice when you write a conjunction, these are pointing in the same direction. So when you write them together, because it's a connected graph, these will point in the same direction. Now, if you look over here, this one here is really not in standard form, but it is as a compound inequality because your negative is on the left. Now, let's look at the next one. All numbers less than -3 or greater than 7. So what are some numbers that would work? So less than -3, well, -5, -4, okay? Or greater than 7, well, 8, 9, and so on. So for this one, you clearly see the word or. So the inequality would be all numbers less than -3 or greater than 7. So if we look over here to the graph, we have an open circle on 3 to the left. We have an open circle on 7 to the right. Now, we never ever write an OR graph like this. It is always connected because the graph, it's always connected with an OR. The graph is always disconnected, so we never do that to that type of problem. Now, if you look at both of these examples, you clearly see the word and OR. Well, sometimes that's not going to happen, and you have to figure out which situation you're dealing with. So, it says all numbers from 2 to 7 inclusive. So what does the word inclusive mean? Well, that means included. Included means you're going to have an equal to sign. Exclusive is going to be not included. So all numbers from 2 to 7, what would that be? Well, 2, 3, 4, 5, 6, 7. So you can clearly see we have a connected graph. So when we do the inequality, we can go straight to, okay, x is less than or equal to 7, okay, but it's also greater than or equal to 2. And I know that because x is in this range. So from the graph, we have 2, we have 7, and it's all numbers in there inclusive. So that means everything 2 to 7 included. Now, here at the bottom part, it says write an inequality for the statement and draw its graph. So what I would like for you to do is to pause the video and try 1 and 2. Okay, so for number 1, all numbers from -2 to 4 exclusive. So the exclusive excludes the -2 and the 4, but it's everything in between. So your inequality could be -2 and 4, x is in the middle. It is less than 4 and greater than -2. Now, I think that's the easiest way to write it. You could actually write it this way. X is greater than -2 and x is less than 4, but this way is easier to write as a conjunction. This one over here, all numbers less than 4 or greater than 5, that's what the graph looks like, and this is the way it would translate. X is less than 4 or x is greater than 5. Now, the next part gives you a graph, and then from the graph, you have to write the inequality. So pause the video and try this one. Okay, check your answers. For this disjunction, we have an or. So it is x is less than -1 or x is greater than 2. And for number 4, we have a conjunction, and we have x in the middle. So x is greater than -1, x is less than 2. Now, as we study compound inequalities and you realize it's two inequalities put together, there is actually a different notation. It's almost a shortcut to write compound inequalities. So now if you'll flip your paper over, we are going to look at a brand new notation, and it is called interval notation. So interval notation is just a method for writing down a set or a group of numbers. So this top blank, you need to write down interval notation. Now, it is used to describe a range of numbers along an axis. So what we are going to do here, we're first going to look at some easier examples just so I can introduce you to this concept. So we've been looking at all real numbers greater than 5. So we know x is greater than 5 is how we would translate that. We know on the graph it would be an open circle and it would go to the right. Now, there is a brand new way that we can write this with interval notation. So the first thing you have to know is how you enter an open circle. So what you do is an open circle does not include the number. It is an open parenthesis. So you say open parenthesis 5, comma, and this ray indicates that it goes on forever to infinity. So we say positive infinity. And infinity is never closed, it is always open. So that is what interval notation looks like. So now what you have to get used to is when you see this, or even the graph, you have to know that all three of these mean the same thing. Now, what about a closed circle? All real numbers greater than or equal to 5. So x is greater than or equal to 5. So the graph on this one is a closed-in graph, and then it goes to infinity. So a closed-in graph is a bracket 5 to positive infinity. Infinity is always open. Now, all real numbers. All real numbers really doesn't have an inequality, okay? But you all know the graph is completely covered with all real numbers. So this is how you would write all real numbers in interval notation. It goes forever to infinity to the left, so that would be negative infinity, and it goes forever to infinity to the right, so that is positive infinity. Notice you have two open parentheses. So remember, okay, includes the number is the bracket. It is called the inclusive bracket. So it includes everything. That does not include is the parentheses. This is called the exclusive bracket, okay? So this one here is the closed, this one here is the open. Now, with compound inequalities for conjunctions with interval notation, it says all real numbers greater than or equal to -2 and less than 3. So for this one, all real numbers greater than -2, so greater than or equal to -2, and less than 3. So we can start it out like this so we can see the graph. We have closed in on -2, we have open on 3, x is greater than 2, and less than 3. So you could also write this inequality -2 and 3, x is between them, it's less than and greater than or equal to -2. Now, if you're doing interval notation on this, what you have to do is you have to look at the left side and you have a -2 there. Now, it is closed in. So for this one, it is a bracket 2, comma, this one does not go to infinity, it comes up to 3, but 3 is open. So what this one would look like, you would have a negative 2 there, comma, up to 3. Now, look at the next one. All real numbers from negative 2 to 0 exclusive. So, for this one, we have negative 2 from negative 2 to 0 exclusive. So the graph looks like this. The inequality would be negative 2, 0, x is in the middle. X is less than 0, greater than negative 2. Now, interval notation. We have two open circles, so we're going to have two parentheses. So parentheses negative 2, comma, 0, parentheses. Now, I know that looks like an ordered pair, but you have to know that it is interval notation, not an ordered pair. Now, pause the video and try that third one. Okay, all real numbers from 4 to 7 inclusive means everything from 4 to 7 included. You have two brackets because they are closed in, so it is 4, comma, 7, both ends closed. Now, if you'll look, these are all compact. They are in interval notation, and these are all conjunctions. Now, the last thing is, how do you write disjunctions in interval notation? Well, there is a new symbol that you have to know, and it is called the union symbol, and it indicates or, and it is simply a U. So, for this one, remember these are disjunctions, they will be disconnected. So, all real numbers less than 3 or more than 5. So the inequality will be x is less than 3 or more than 5. So as we go over here and graph it, x is less than 3 or x is greater than 5. Now this one you can clearly see you have two pieces with the word or, but we don't use the word or anymore, we use the union symbol. So we have to focus on each side. So this side is going to negative infinity. So we do an open parentheses, negative infinity, up to 3. 3 is open. Or we use the union symbol. We go from 5, which is open, to positive infinity. Now you can see a disjunction looks a little bit more complicated, but all this is indicating is this is 3 to infinity or 5 to infinity, and it's describing that graph and that inequality. Now let's look at another one. All real numbers less than or equal to negative 1 or greater than 4. So here's our negative 1. This time it's closed, and it goes to the left, or greater than 4 goes to the right. And now interval notation. This one is going to negative infinity up to negative 1 with a bracket because that is closed, or it's going from 4, so that's going to be a parenthesis, 4, comma, positive infinity. And remember, your infinity is never ever closed up. It's always that exclusive bracket. Now, you pause the video and try the last one. Okay, so for the last one, did you get x is greater than or equal to negative 2 or x is less than 5? I just realized I made a mistake. This one's not going to be equal to. So this guy here is open, and this guy right here will be a parenthesis. So make sure that one's open, make sure that one's open. So now let's see if I've got this correct now. Less than negative 5, okay, actually this is the open one. So sorry about that. This is open, this one's closed. So this is a parenthesis, or greater than or equal to negative 2, that's the bracket, and then it goes to positive infinity. And that is it for this lesson. Your notes are now finished.